I will never discuss that. I will never discuss that, but I have to when x approaches infinity or negative infinity. So which of these two is the most powerful?
Squared.
Right.
Squared.
Right. So this is too small to mention. So when x approaches infinity, where is this going? Because I have to plug it in. I don't know what this is.
Positive infinity.
Of course. Stay with me. When x approaches infinity, where is this going with a minus in front?
Negative infinity.
Good. This is a third situation called indeterminate. So we already know 3 out of 7. So 3 out of 7 indeterminate cases. In other words, the answer can be 1500, it can be 0, it can be -2, -2. I don't know. Question, how do we proceed? Something we always did with these functions.
Conjugate?
Exactly. Thank you so much. 9x squared plus x plus 3x. Same thing in the denominator, mandatory. Plus 3x. Exactly. Thank you. Good. So now we have limit as x approaches infinity. I will write the easy part, and you'll give me the difficult part. So can anyone multiply those two for us? Anyone?
Is it 9x squared plus x minus 9x?
Brilliant. You mean 9x squared?
Oh, sorry,
Yes.
9x squared.
Perfect. Excellent. Thank you, Dylan. This times this is this, minus this times this is this. Excellent. Goodbye to these two. And now, inside the square root, I have to do exactly what I just did here. Factor out the degree. So I have limit. So please see, I do not drop the limit operator. I have not applied it yet. So I have to keep it all the way. Okay, x at the top. What is the degree inside?
2.
Good. So we have to factor out x squared. Can anyone give us these two terms? Of course, with plus in the middle.
Nine plus 1.
Over x.
1 over x.
Always take a moment. You don't have to rush. So x squared times 9, is that correct? Yes. Is x squared times 1 over x, when you simplify an x, is that? Yes, that's correct.
Yes.
Perfect. So now, the square root of a times b can be rewritten as the square root of a times the square root of b. I have to use this property here. Also, remember what the square root of x squared equals to. And we have to remember that this is the absolute value, which in turn is x for x greater than or equal to 0 and negative x for x less than 0. That's why we talked about this absolute value. It pops up all the time, even in limits. So because x approaches infinity, what will I replace the square root of x squared by? Will I replace it by x, or will I replace it by negative x?
X.
Of course, because positive infinity is here. Okay, so let's continue. So we have limit as x approaches infinity, x over. So this is my first step. I have to write this first step for everyone to see. And then I will say that I will replace this by x because x is greater than or equal to 0. So I continue. Limit.
You have to add that.
I do
Okay.
because if x approaches negative infinity, the square root of x squared will have to be replaced by negative x.
Okay, thank you.
Thank you. So limit as x approaches infinity from x over x, the square root of 9 plus 1 over x plus 3x. What do you think I am going to do next?
Factor out a 3, or an x, sorry.
Brilliant. Who was that?
Katie.
Thank you. Why would I even want to do that? Here it is. Now I drop the limit operator because I'm applying it. Can anyone give us the answer, final answer of this? Keeping in mind that this will approach
Zero.
excellent. So then what do we get?
1/6.
That's it. Which means y equals 1/6. Horizontal asymptote, this is not a rational function. We cannot assume that it's a horizontal asymptote at both ends. I can only say at infinity only. Because I use this. I don't know what happens at negative infinity. I don't even know if it has a horizontal asymptote at negative infinity. Okay, so this was, yes?
Never mind. I get it. I'm good.
I love it when my students answer their own questions. Okay, so I would like to look at something like something with arctangent, of course, and also some exponentials. So let's say limit from e to 3x minus e to negative 3x over e to 3x plus e to negative 3x as x approaches infinity. Yes, this looks scary. Not at all. Okay, when x approaches infinity, which of these two terms or these two terms is the most powerful one? E to positive 3x or e to negative 3x?
Aren't they equal?
Careful. Very good. Let's discuss that. I'll come back. See, e to 3x looks like this. But e to negative 3x is this. Or this. Which looks like this. So then, from these two, which one is the most powerful?
By powerful, what do you mean exactly?
Very good. So from these two, which one is more powerful when x approaches infinity? Which one blows up faster with larger numbers? More powerful.
So
I have a specific question.
Yes?
Let's just say that instead of asking as it approaches infinity, what if it said approaching negative infinity? Would we then use the e to the negative 3x?
Yes.
So the stronger one is the one that in the direction you're going is higher.
Exactly.
Okay.
So maybe I should say which one is stronger. When x approaches infinity, which of these two is stronger?
E to the 3x.
That's exactly what we're going to factor out. Do we all understand why e to 3x is more powerful, stronger? Yes? So the concept is the same with here. Which of these two is stronger when x approaches infinity? Of course, 9x squared is more powerful. When I square infinity is not the same with not squaring infinity. So this is much smaller. Just keep in mind, let's say 10,000. Is 10,000 smaller or bigger than 10,000 squared? Well, of course, it's smaller than 10,000 squared. So the same idea here. This one goes to 0. This one goes to 0 when x approaches infinity. We looked at the graph, but these are very large numbers. Good. So this is what we are going to factor out. So now let's see what we have in parentheses. Definitely 1 and 1. But now, how do I continue? So from negative 3x as the power, I have to subtract 3x. So then this is e to negative 6x. And you can say, wait, let's check. Okay, let's check. E to 3x, e to 3x times e to negative 6x. I copy the base, and I have to add the exponents. That's the exponential rule. Copy the base, add the exponents. Same thing here. E to negative 6x. Yes, of course, that was the whole idea. Oh, I forgot to say, of course, this is infinity over infinity. Okay, and now, where is this going? And where is this going?
Does it matter that the top is minus e to the negative 3x and the bottom is plus e to the negative 3x?
You mean the sign in front?
Yes.
No, it doesn't matter.
So
I didn't,
how-
oh. I'm sorry. I didn't copy it, sorry. Thank you, my apologies. Of course, I have to copy what I have. I can't change the problem. I can change the presentation, but it has to be the same. I have to copy plus. It had nothing to do with it. I just simply didn't copy it. My apologies. So where is this going?
0.
Oh, of course. Where is this going?
Zero again?
Yep. And what is this limit? Now I dropped the limit operator because I'm applying it. I already did by writing this.
The 1.
Exactly. Which means y equals 1, horizontal asymptote at infinity.
How did you get the e to the negative 6x again?
Okay, so remember when we, let's say, we have x to the 4th minus x squared, and I factor out x squared, right?
Yes.
So from power 4, I subtract power 2, and I have power 2. From power 2, I subtract power 2, and I have power 0. So if I have e to 3x minus e to negative 3x, and I decide to factor out e to 3x 3x minus 3x is 0, right? So I have 1 minus, from negative 3x, from 2 I subtract 2 to get 0. From 4 I subtract 2 to get 2. From negative 3x I subtract 3x to get e to negative 6x. Now I stop, so let's check. E to 3x times 1, check. E to 3x times e to negative 6x, I have to copy the base and add the exponents. Check. Is that okay?
Yeah, I understand now.
Better?
Yes.
Okay. I wanted to look at arctangent, and also we know now that the limit, oh, I don't, this is not a good color. So limit as from natural log x as x approaches infinity. We looked at a lot at the limit as x approaches 0 from the right of natural log x. Can anyone refresh our memory on this? As long as you have the natural log function in your mind, you will never forget what this equals to.
Log base e.
You mean negative infinity, right?
Oh.
Right? This is the graph. And now, based on the graph, what will you say about this?
Would it also be infinity?
Infinity, yes. Very good. So there is no horizontal asymptote. Let's also look quickly at the exponential. So what about the limit as x approaches infinity from e to the x? You have to picture the graph.
Infinity.
Careful. We have to picture the graph. Yes, I'm sorry. I was thinking already at e to negative. My mind was already.
You scared me.
No, I didn't mean to. Sorry. My mind was already on this. What about e to negative x? Well, you know that this is limit as x approaches infinity of 1 over e to the x. What will you say? If the denominator goes to infinity, 1 over infinity will definitely go where?
Negative infinity?
1 over infinity. I have $1 and I want to share it with everyone on the planet. And when I get to your door, how much will be left from that $1?
0.
Absolutely. So y equals 0, horizontal asymptote at infinity only. So when we divide a number by something huge, the answer or approaches 0. If this is fixed and this is huge, the answer for the limit will be 0.